So the first question for you, quite easy, and let's see how far we can take this concept to. There is a mass M and there is a force F. If you want to give values, I'll give value to it. F is equal to say 20 Newton, M is equal to say 10 kgs. Now there is no friction. What would be the acceleration? What would be the acceleration? So that is your first question over here. So that's pretty simple. We will first analyze, look at it and see where all it can go. We will make all the forces on the thing. It can't go up, it can't go down, it won't be going up and down because this is a rigid floor what I have made underneath it. So the acceleration most probably will be, or it must be, in the horizontal direction. So we have to ensure the way of the acceleration first, and then we have to make all the forces on this body. So what are the forces on that body? And then when we make the forces on that body, we say we are doing a free body diagram, as if the body doesn't know that there is a floor below or whatever. It is going forward with a acceleration and it is experiencing a bunch of forces. The net resultant of that must be in the forward direction. Therefore it is going in the forward direction, because F and A direction, ultimately the total F and A direction must be same. So what are the forces on the body? We have to carefully analyze and identify all the forces on the body. Remember, Earth is present. The point that we are saying that is it is going to stay on this platform is because Earth is pulling it. So Earth is there, it is pulling the body down. Why it is not going down? Because the table is giving a reaction upwards. So maybe equal, maybe not, or whatever. So that was your pull of the Earth, mg. That's drawn over there. Now forces on the table I am not drawing yet. On the table there will be different forces. There will be force of the body down. So the other force what is drawn is the normal reaction from the table. So these are the forces. Any other force on the body? No, no other force. Now what we can do is we can resolve all the forces in the direction of acceleration and 90 degree to it. Thankfully all the forces are in the direction of acceleration and 90 degree to it. So the ones which are 90 degree to it is not responsible for the acceleration. The ones which are 90 degree to it is responsible for a perpendicular acceleration which is not present in this case. So we can say that total y vertical must be equal to mass into zero acceleration, which is in the vertical direction. There is zero acceleration, meaning to say total y vertical must be zero. So is it so? Let us see. N is up, n is upwards, mg is down. So total y is n minus mg or mg minus n. N minus mg, if we are considering upward as a y, downward is mg minus n is a y. This must be equal to 0. So by inspection we know that there is no acceleration in the vertical direction, hence we know that the normal reaction is mg over here. So we have to do so much to find out or to ensure that mg is n is mg, which is not going to be so in all the cases. And what about the horizontal thing? Horizontal thing, F is equal to mass into acceleration. That's the only force in the horizontal direction, and that's the horizontal acceleration. So we have this equation. So if you put the values, what we get is 20 is equal to 10a, or a is equal to 2 meters per second square. Quite simple. No, there wasn't any need to even discuss it, right? But let me now go a bit ahead on the same thing, and then we'll see the use of the discussion. Say this mass was in fact earlier two pieces. One was say 6 kg and the other was 4 kg. And you were pushing it with F, which was equal to 20 Newton. Now I have to study these two masses separately. This I'll call it as M1 and this as M2. So M2 in red. that is 4 kg. So what would be the acceleration? If both are considered as one body, then we have got the acceleration, which is 2 meter per second. Now separately also their accelerations must be the same. So let the acceleration of this one is a1 and this one is a2. A1 must be equal to A2 by inspection. If A1 was greater than A2, then 6 will go into 4. Then it was not a rigid body. If A2 is greater than A1, then this 4 is going to separate out, which is not possible. If I am pushing on the back, then the body which is in front can't just separate out. So by our physics knowledge and the knowledge of the situation, we can say A1 is equal to A2. So let us call it as A. Now how do I make the forces? Now how do I make the free body diagram? So just concentrate over here. That's your M1, that's 6 kg thing. It is being pushed from the back with F force. And then what is M1 doing? I'm just concentrating on M1. So what is M1 doing? Is M1 free to go ahead? It is not that free. There is a mass ahead and it is actually pushing that mass. Why we know that it is pushing that mass? Because that mass went ahead. That mass had an acceleration in the forward direction. Why it was having an acceleration in the forward direction? Because it must be receiving a push from the back. If it is receiving a push, I'll call it as R, then this is going to get an equal and opposite push towards the back. I'll call it as, yeah, that is called R, so this will be R. It is an equal and opposite on two different bodies. This pushes that with R and that pushes it back with R. That is your third law, which is a law. There is no debate in that. So what is the net force on this body horizontally? See, I'm avoiding making the vertical forces, which is, okay, I'll make it M1G and say N1 normal reaction, but we know it is not going up or down. So N1 must be equal to M1G and has nothing to do with the horizontal acceleration. So what we have on this body, what are the net horizontal forces? F is equal to MA. Left hand side is all the forces what you can see in the A direction. So what is that? That is, it is F forward and R backward. So this is the net force. It is somebody is pushing it forward with 20 and somebody is pushing it back with R. So that's the net force. So if there was a block, somebody is pushing with 20 forward, somebody pushes with 5 Newton backwards, then the net forward is 15 Newton only. So that's the net forward force is equal to mass of this part M1, which was 6 kgs, into acceleration of this block. And what about this one? If I write the equation for that, this is your M2, then it received a push from the back of R, which is same. This R and that R is same. So it received a push of R, and that's the only force which is making it accelerate in the forward direction. So R must be equal to M2A. So these are the two equations which is as good as the old equation, which is F is equal to MA. How is that? If I add the two equations 1 and 2, what do I get? I get F is equal to R and R gets cancelled, minus R plus R. I'm adding the two equations, equation number 1 plus equation number 2 to do away with the R. So I get M1 plus M2A. So that was your old equation. M1 plus M2 was 10. So we get the acceleration as 2. F is 20. This is 6 plus 4 into A. A is equal to 2. We get the same answer. But here we have more knowledge of what is happening internally. So what is happening internally? What must be the reaction over here? I can pick up equation number 1 or 2. Equation number 2 is easier, smaller, so I'll pick that. R is equal to, once we have found out A, we can put R is equal to mass of that part 4 into acceleration 2. 4 kg mass is going with 2 meter per second square acceleration. So it must be receiving a force of 8 Newton forward. So this R must be 8 forward. Shall I plug in this and cross verify? Yes, let us do that. 20 was the forward force on this. 20 was the, where's that body? Yeah, the 20 is the forward force. The backward force is 8, what we calculated. So 8 back, 20 forward. So net force on this is 12. Net force is 12 newtons on the 6 kg mass. So what's the acceleration? 12 by 6, it is going to give you 2 again. So everything falls in place. So the point is, this mass can be broken into several parts. Each part is experiencing a action reaction push, on each part is pushing the other part. So even if it was in several pieces and you had a push from your F, all of them are going to accelerate in the forward direction with the same acceleration as we saw the physical constraints. So we can take all these bodies as a single body and do, instead of going for the action reaction at each place. You can do that also, or you can take it as a single mass M. So here we'll have big blocks all going together. So we are going to take it as a single mass M and we are going to do the question. Now the same thing, if I had pulled it from this side, then obviously only this will move and the rest is left behind. So in case of a pull, we'll rather use a string